Empezamos. Hoy es un día extraordinario. O sea, he esperado tanto este momento. Hoy van a conocer a una persona increíble que no solamente está revolucionando al mundo, sino que me revolucionó las neuronas. Y quiero presentarles hoy a la doctora Kara Fitzgerald. Team Kara here. Y pues obviamente quisiera hacer una introducción más formal para que entiendan toda la emoción, para que entiendan por qué transmito tanta emoción cuando hago esto. Y básicamente la doctora Kara es doctora en naturopatía de la Universidad Natural de Portland, Oregon. Tiene un postdoctorado en bioquímica nutricional, se formó en el laboratorio de Metametrics. Además es pionera, profe y líder de la medicina integrativa y funcional. Enseña medicina funcional a diestra y siniestra en el IFM, perdón, en el Instituto de Medicina Funcional, donde se formó el célebre doctor Carlos Jaramillo. O sea, sí, la profe aquí. O sea, ¡qué increíble! Y por otro lado, también es una investigadora, autora de múltiples estudios científicos, libros, que dentro de ellos Younger You y casos de estudios de medicina integrativa, top, brutales, los amo con todo mi corazón. Y esta es la mejor parte. Esta es la mejor parte, que creo que esto fue lo que me revolcó todas mis neuronas. Y la doctora Kara Fitzgerald es la creadora del plan, que a mi modo de ver es el plan más revolucionario, más visionario de la salud integral, donde se puede revertir hasta 7 años de la edad biológica. Brutal, ¿no? Welcome, doctor. ¿Cómo está?
Gracias. Está muy bien. Estoy muy bien. Ya, sí. Muy emocionado para hoy. Sí.
Para empezar, bueno, también me hizo falta decirles que la doctora Kara es bilingual.
Un poco.
No,
Yo
tampoco no.
yo intento.
Pero, pero bueno, lo que decíamos, es mejor practicar, es mejor hacer todos los días algo que no hacer nada nunca. Entonces, pues, directo al grano, vámonos a entrar en materia para que entiendan la importancia de hacer todos los días, porque creo que lo más importante aquí es hacer todos los días versus 2 días. Uh, by the way, I'm gonna talk in Spanish and in English. Esta conversación va a ser bilingual, va a ser Spanglish, porque pues todo lo que esté contando la doctora Kara voy a intentar traducírselo, y también vamos a utilizar unas aplicaciones nuevas para traducir al español. So, first of all, what the heck is epigenetics?
Epigenética. Yeah.
Genética.
Let me tell you the background, and you can stop me if you want to, if you feel like, if you want to translate, or if you're going to come back after and translate. But I can stop, and then you can translate if you want to, if that works. But so epigenetics is epi means above. I think it's Latin for above. Epi. Genetics is our genetic material, our DNA. And so epigenetics is what sits on top of our DNA and regulates which genes are on and which genes are off. We thought that our DNA was most important, but what we now understand that in fact, it's our epigenetics. It's what regulates what's on and off that's really more important in terms of our health span and our lifespan. So epigenetics is where science is really getting deeper and deeper into, and it's pretty complex. Our genetic material, our DNA, is actually relatively simple. We've got about 23,000 genes, and our genes don't decide whether we're going to get a disease. We thought that that was the case, but in fact, it's really what genes are on and off. And this is the field of epigenetics. And what we understand very clearly is our lifestyle choices, how we live day in and day out, really influences gene expression, epigenetics, and therefore it influences our health and our lifespan.
Okay, and I think that the basic concepts are really, really important to this interview. So I wanted you explain what is methylation, what is methylation, the DNA methylation, and what is the difference between those?
DNA methylation and methylation in general, more broadly. Sure. So methylation is this incredibly fundamental process that is happening in every cell of the body all of the time. There are hundreds of enzymes that engage in methylation, and all that is a carbon. You can remember from chemistry in school, a carbon and 3 hydrogens. It's this incredibly simple molecule, and we put this, it is called a methyl group. We put methyl groups on to structures in our body, and then we take them off. So this it looks like a red lollipop in science. So you'll see this red lollipop gets placed on a molecule, and then it gets removed from a molecule, and that's happening all of the time in the body. It helps us make hormones. It helps us make neurotransmitters. Dopamine, the all-important brain neurotransmitter, adrenaline, noradrenaline, acetylcholine, all of these incredibly important compounds that really help our bodies run, help our brains think, help us feel good. They're made and metabolized via methylation. We transform estrogen with methylation. We get rid of toxins in the body through methylation. So methylation is just working all of the time. And one of those fundamental methylation processes is DNA methylation. This is one of the epigenetic marks. There are 100+ ways we can regulate what genes are on and what genes are off. But one of the most important ways we do this is through methylation. So again, red lollipops, when they are on a gene, that gene cannot be then turned on. The red lollipops sit at the promoter region of the gene, and when there's a lot of them there, that gene cannot be expressed. When the lollipops are removed or they're inhibited from being placed onto the gene, that gene can then be on. The simple take home for us, what we want to do is obviously keep the healthiest genes on and inhibit those genes that promote disease. I want to actually add an interesting piece about methylation. And the reason that it's so important in epigenetics, like why DNA methylation is so important, is that the marks, those red lollipops, can really last. In fact, we've got enzymes in the body that will maintain this pattern. And so cell division after cell division after cell division, enzymes can keep these patterns, can dictate what genes are on and what genes are off. So, for example, it's through methylation that determines that a cardiomyocyte or a heart cell remains a heart cell, or a liver cell is a liver cell, or an eye cell, it remains an eye cell. It's these methylation patterns. They last and they're reliably reproduced over generation after generation of cell division. Another really interesting piece about methylation is that not only cell division in our own bodies, but we can inherit patterns from our parents, from our grandparents, and generations even earlier. So we know, for example, if our grandparents' generation experienced war or experienced famine, that can influence our DNA methylation patterns and predispose us to conditions like diabetes, heart disease, maybe anxiety or depression. Likewise, although less studied, are patterns of resilience. So we can inherit, strength from our parents and grandparents and great-grandparents. In fact, patterns of exercise can be handed down through the generations. So there's a continuum of epigenetic patterns. Some are very resilient. An eye cell is never going to turn into a liver cell. Those are always going to be preserved. But there's much that we control, that our lifestyle choices day in and day out will influence our own health profoundly, and then the health of subsequent generations if we're to have kids.
Yeah, wow, it's interesting. Es muy interesante. And,
Sí.
and I want to share with people the phenomena, the issues that makes this epigenetic change. I mean, hypomethylation and hypermethylation. And bueno, voy a hacer la traducción aquí para que me entiendan. Y estos trastornos trastornos epigenéticos, estos cambios epigenéticos, o que se apague poquito o que se apague mucho, define muchas cosas en el cuerpo. Por ejemplo, me adelanto aquí, I'm gonna accelerate a little bit. Y cuando un gen que normalmente apaga tumores, como BRCA, o bueno, lo que quieran, este se apaga, se vuelve un problemón, porque si no se apaga, el que apaga genes supresores de tumores, pues se manifiesta el tumor. So, what are these changes that create in the genes? I mean, what is the trouble of hypomethylation and
Sure.
hypermethylation?
Yeah. Yeah, so hypermethylation would be turning a gene off. Lots of those red lollipops on the gene will inhibit that gene from being turned on. Conversely, hypomethylation would be, just a few, allowing that gene to be turned on. Okay, so lots of red lollipops. Basically, you can just imagine it blocks transcription from happening. That gene cannot be transcribed, whereas a few red lollipops, transcription proteins can get in there and turn the gene on. Generally, what we think about hyper and hypomethylation, those are sort of terms used when something is bad, when a gene is hypermethylated and inappropriately turned off. So what's interesting about aging is that we start very predictably, changes happen to gene expression. Hyper and hypomethylation patterns happen during the aging journey that make us vulnerable to the diseases of aging. And this is where our research sits. So as we age, we start to inhibit or hypermethylate protective genes, and we actually turn on genes that drive disease forward. And this is a huge piece of why aging is the biggest risk factor for these chronic diseases of aging. Aging itself is a way, way bigger risk factor for cancer than is smoking, for example. Isn't that extraordinary?
Yeah.
Aging changes gene expression, making us vulnerable. So classically, the example that actually brought me into studying epigenetics was the fact that cancer takes over gene expression. Cancer takes over epigenetics from us and will turn genes on that drive its growth forward and will turn genes off that inhibit. So there's something called, there is a huge class of genes called tumor suppressor genes. You certainly learned in school about the BRCA genes that increase risk for breast cancer, ovarian cancer, and so forth. These genetic mutations that are, actually they're a small percentage of all cancers, but if you have this genetic mutation, that your likelihood of getting cancer is very high. That's a tumor suppressor gene. Then there's all sorts of other tumor suppressor genes. As we age, our body starts to shut these genes down. So when they function properly, they protect us from cancer. Tumor suppressor genes, as the name implies, protect us from cancer. But as we age, we start to hypermethylate them and shut them down. It's crazy. You know, it's like, it makes no sense, but then we can talk about programmed aging if we want to. Like, there's a reason for these diseases becoming, you know, us becoming vulnerable as we age. So tumor suppressor genes are inhibited as we age. They're inhibited in cancer, and something called oncogenes, genes that drive cancer forward. As we age, those genes are turned on, and likewise in cancer, those genes are also turned on. So if you look at the aging epigenome, you will see that these changes sort of painfully reflect some of the changes associated with the chronic diseases of aging. Does that make sense?
Literal, me voló la cabeza. It's amazing because
Yeah.
I don't know, it's like crazy because science study every single day, maybe every single day, the same thing or the same topics, but many people or many scientific forget this. Like, it's, I mean, 95% of the diseases, all diseases are epigenetics. So what the heck? But anyway, so you talk about the predictors of these changes, like los hábitos, hablaste sobre los predictores de los cambios epigenéticos. So what is the most dangerous thing that harm or epigenetics?
Yeah, that's a good question. I would say that, well, probably, I mean, I would say right now, probably nutrition, you know, poor diet. That's a massive damaging player. If we're not eating well, I mean, think of our food as information. If we're putting poor information into our bodies, we will change gene expression, pushing it towards disease. And the diseases that we get, diabetes, heart disease, you know, again, cancer, dementia, these are pro-aging. So when you have these diseases, you're aging faster. And you also promote getting these diseases when you put very poor quality nutrition into your body.
Like
but I also, go ahead.
Like some vegetables, like exercise.
So you want, see, that's right. Yeah. Por supuesto, necesitamos, you know, saludable, verduras y frutas y, you know, carne y pollo y pescar, etc., you know, etc. So we want to put the best information in the form of food into our bodies, but we also want to de-stress. So like when you ask me what the most dangerous things are, I think poor diet, but also high stress. So the clock, the way that we look at gene expression and aging, much of the tool that we use is influenced by stress. In fact, stress influenced this tool, this biological age tool, really more than any other variable. So I think I just think that we need to take stress very, very seriously. And there's a, in Estados Unidos es un muy estrés aquí, muy estrés en Estados Unidos, sí. You know, a lo mejor es más trabajo y you know, unas cosas aquí, pero estrés es demasiado grande aquí.
Yeah, how is the impact? I mean, you have mentioned it in your book, Younger You, that stress impact on methylation. So
yes, it's
how
pro
much can we make like a measure? I think, o sea, se puede saber qué tanto afecta el estrés a los genes.
We think so. We think like como 25%. I don't know how to say percent, but percent, sí. Yeah, like 25% of the clock, you know, el reloj de edad, de biológica edad, reloj de biológica edad,
Biológica.
biológica,
No,
difícil
man,
palabra.
you're good. I really appreciate because you have an amazing Spanish. Tienes un español increíble. O sea, aprendes muy rápido. Aprendes muy rápido. It's like
Gracias.
mind blowing.
Yo intento, pero like 25%. It seems that so we know from science that stress makes us age. Stress makes us increases our vulnerability to to diseases of aging. Stress is just a huge variable that we have to appreciate. But again, but I also really, when I look, all of these things are important. Like, so I don't, it's not really fair to say one thing is the end, is everything, because all of them are important. So we need to have de-stress practices. We need to know how to take care of ourselves in that way. We need to be able to eat the best foods that we can. We need to move our bodies. Exercise is one of the most important, if not the most important. Again, it's huge. It plays a huge role in epigenetics and in DNA methylation, exercising. If we are exercising, we will be younger. If we are not exercising, we will be older. It's really that, it's that simple. And we don't necessarily need to go crazy with exercise, with very extreme exercise. It can be simple. Our study, the exercise was very simple. And we need to be, let's see, you know, I guess sleeping as well as we can. So exercise, nutrition, decent sleep, some kind of a good some kind of a practice to help us de-stress. And those are really some of the most important foundational pieces that we can do to live long and to live healthy, and to actually transmit that information to our offspring. You know, if we're going to go on and have kids, like the kids that you're going to have, Dr. Franco.
The kids, me queda la duda todavía. Yeah, no kids for now, no kids for now, please.
Yo sé.
Am I younger you? Yeah, it's crazy, but it's amazing. I mean, it's going to the basics like exercise, nutrition, stress reliefs, like I think the exposome, the environment,
Sí,
it's
the exposome, sí.
huge.
Yep.
Muy importante.
Muy importante, sí.
And it's not only like pollution or I don't know, radiaciones o lo que sea, sino también las personas, people, the people you surround.
Yes.
It's much important.
It is huge. That's you're absolutely right. So in our study, we couldn't include community. Like we have a randomized control study. You can't make one group not have community and the other group have community. Like you just can't control. But yes, community, connection, partnership, love with humans, but also with pets, you know, like just connection is incredibly important for our epigenome, for our lifespan, for our health span. Connection is hugely important.
Sí.
And the other piece that you said is, you know, keeping our lives as clean as possible, like, you know, trying to avoid exposure to toxins.
Yeah, es como, o sea, ya sabemos que vivimos en un mundo muy tóxico, ¿por qué no hacer como prevenir intoxicarnos más? ¿Sí? Es muy importante, no solamente las toxinas medioambientales, sino también las toxinas a las que nos exponemos, como algunas relaciones tóxicas que tenemos. Ahora que hablabas de nutrients, I think nutrition is como la
pinnacle.
es the base, es la base de todo. Y es epinutrients. I have here matcha, and I love this epinutrient, but
Sí.
I also love coffee. Los epinutrientes, ya la doctora Kara nos va a contar qué son y la importancia de consumir en suficientes cantidades. So, what are epinutrients?
Mm-hmm. Yeah, I think this is a very cool part of our work. Muy genial. Parte de mi trabajo, mi ciencia, is epinutrients. These are foods that put those lollipops where they should be. So we need to do two very important things. We need to make those red lollipops, we need to make those methyl groups, and then we need to put them in the best places so that the genes that we want on are on and the genes that we want off are off. So there's two steps, making the red lollipops and then putting them where they need to go so that we have the best health. And that's two groups of nutrients. That's two groups, the methyl donors and then what we call the methylation adaptogens, these two groups of foods. Methyl donors help us make the red lollipops. These include things like B12 and folate, choline, betaine, and then a host of other nutrients. But the main ones in methyl donors are folate and B12, choline, betaine. We can get these things in veggies, like this is my lunch. This lunch is dense. There's mucho folate. Yeah.
Superpower.
Yeah. So, but also in my vegetables are the methylation adaptogens. So my salad has broccoli, it has spinach, it's got arugula, it has carrots, peppers, etc. And in addition to methyl donors, there are tons and tons of methylation adaptogens. These are polyphenol compounds. They don't make the red lollipops, but they seem to direct where those red lollipops actually go. And so that's something that we studied in our research, seeing that we were able to, in the group that followed our intervention, in the study group, we were able to rearrange where DNA methylation was happening to something more healthful and more youthful. And we think fundamental to what we did was, this particular diet that's very dense in methyl donors and methylation adaptogens.
This is the best. Esta es una chica, es increíble. I'm gonna make like a little example to explain. Because when I was learning about epigenetics, I was like, oh my, I don't understand. So I have to read and read and read again. So los methyl donors son los donadores metilo. No se asusten por los nombres raros. Ya estamos en el proceso de adaptarlos en un lenguaje más óptimo. Entonces, los methyl donors y los adaptógenos de la metilación del ADN. Nombrote, ¿no? Entonces, los methyl donors son como la Madre Teresa de Calcuta. A todo el mundo le regala algo. Le da y le da y le da. Donadores metilo, y lo que dona son los methyl donors, o sea, los grupos metilo para apagar los genes. Bien, vamos bien. Ahora, por otro lado, están los adaptógenos de la metilación del ADN, que como su nombre lo dice, adaptan la metilación, adaptan este proceso de apagado para que no se apague mucho ni poquito, solamente lo suficiente. Entonces estos adaptógenos, o llamémoslos epinutrientes AD, o adaptógenos como quieran llamarlos, lo que hacen es barrer el exceso de los methyl donors para que así haya unos genes poderosos, power, y haya un balance. Recuerden que no es o que se apague poquito, hipometilación, o que se apague muchísimo, hipermetilación. Es solamente que se apague lo que es. Entonces, para ello, todos estos epinutrients, están presentes en toda la comida real y especialmente en la que a veces le hacen el feo, que son las verduritas. Uy, ahorita hablamos, Ahorita hablamos del liver. Ahorita hablamos del liver.
Yeah.
Yeah, liver. Oh, I don't like liver, but liver.
Sí. Liver es muy difícil para, like del mundo.
Yeah. Entonces, los epinutrientes lo que hacen es darle la materia prima para que nuestros genes y nuestra estructura biológica, que es una maquinaria increíble, trabaje como debe trabajar. I want to ask you, because I think in this world of now, the world of now, I want to now. It's the same eating folate that taking acid, like taking in pills. Like
That's a really good question. No, I don't. I think that folate and all of our vitamins, the more that we can take as food, so getting our vitamins within the food matrix, it's information. Again, thinking about everything as information, it's information más importante que vitaminas solas. Sí, más importante. Sí, food. Comida todo.
Es como un bombazo de vitaminas. It's not one thing. It's all things that work together.
Yes, it's this complex synergistic interaction. The food, like, one forkful of this salad, has hundreds of thousands of distinct pieces of information that interact with each other, interact with my digestive juices in my mouth, and then in my stomach, and then my microbiome, the microbiome, y cambiar los comidas, and then in mi cuerpo efecto bueno mis epigenéticas.
Good. I understand. I don't know, but I understand everything you say. It's like cool. It's awesome. You are awesome. You are awesome. Yeah. I recently listened a podcast of Dr. Mark Hyman and Daniel Amin. They were talking about that, about it's not one thing, it's the whole thing. It's not only vitamin C, vitamin A, or I don't know, omega 3. It's like the whole thing. So, para la audiencia, quiero que quede clarísimo. Y no es más importante una cosa, sino todo. No es lo que uno hace un día, sino lo que hace alrededor del día. No es solamente el suplemento. Los suplementos son eso, son ayudas, son extras. Que hay algunos que hay que suplementarse. Like magnesium. There are some supplements like...
Muy importante. Sí.
Magnesium that is really important.
Yep.
And some extras like liver in caps for people that don't eat liver.
Yes.
El hígado, las vísceras son increíbles, son muy buenas, pero hay personas como yo que no las comen. Entonces, hoy afortunadamente, oh God, por favor, gracias, Diosito. Existen el hígado en capsulitas. So can you talk about this, about supplements? Like, what are those that are really important and those that are not that much?
Okay, this is it's pregunta muy importante. A veces necesitamos supplements. A veces necesitamos vitaminas extras. Like, so sometimes we need more folate in a capsule. Sometimes we need more B12. Like, I don't want to say not to take supplements. I take supplements myself, and as a doctor, I prescribe supplements to my patients all the time. So there's an important place for when we need them, but we don't want them to replace food. We don't want them to replace exercise, sleep, etc. We want them to just be added as necessary. And for things like B12 and folate, and especially folate, we don't want to stay on it necessarily forever. We want to use food. And for people who are interested in that, I talk about more details around why in the book, which hopefully will be in Spanish one of these days. Yes, so most of us need extra magnesium. Most of us need extra omega-3, so fish oil. Most of us could use a probiotic, or we can do fermented foods. Most of us need vitamin D, even if we've got tons of sun, like you guys in Colombia, tienen mucho sol, pero probablemente necesitan más vitamin D. So those are some foundation important vitamins. También yo uso más turmeric.
Oh, yeah.
Porque turmeric es muy importante epinutrient, methylation adaptogen. Y cuando yo no puedo comer turmeric, yo voy a usar en cápsula, porque es muy importante. También con green tea y sulforaphane y resveratrol. So epinutrients a veces está bien para usar en cápsula.
Yeah, and of course, there are many people that eating, algunas personas, es difícil la comida because have this, I don't know, stomach issues or gut issues, and supplements are like an extra, like a tool para mientras tanto, like for now.
Mm-hmm. That's right.
Things get better. So supplements. What do you think about adaptogens? I mean, like ashwagandha, rhodiola, kava.
Mm-hmm. I love them. I think they're fabulous.
So, okay, for the last thing, how we can reprogram ourselves, like create a healthy backup. Like you have a backup in your phone. How do you create a backup in your biology to live better and be better?
Yeah. So step by step, we change. So poco a poco, cambiar los información en nos vida, en los cuerpos. See, like we just want to slowly change the kind of information that we're telling ourselves, the information in terms of our food, exercise, our sleep, our stress, our community. The more intentionally we live our best lives. And I do think that it's important to incorporate the epinutrients that we identified in the book as well. The more that we can do these things, I think that we are able to change how well and how long we will live. It's incredibly powerful.
Wow. Incredible like this interview. I hope you guys, espero que ustedes lo hayan disfrutado tanto como yo. Vamos a hacer los arreglos de traducción para que se entienda. Gracias.
Sí. Yeah, adiós, mi amigo. Big hug.
Bye. Hug.
Okay, hablamos más tarde, mi amigo.
Chaito.